Very good evening to everyone who are watching this video. So, as I posted a short for graphical representation of motion, some problems, right? So, today we are going to solve that problems. First of all, let's see the diagram or graph, distance time graph. Let's see distance time graph. Observe the time graph. Distance time graph. A, B, C, D. 4 points are given. This is the distance and time graph. So from this distance time graph, we need to calculate the force acting. We need to calculate the speed. Calculate the speed at A to B, B to C, and C to D. Let us know. We know that. See, as we already discussed, distance time graph. In distance time graph, the slope is explains about the speed of the body. So from the slope, just imagine that here A, B, C, D. Here let us take some point like P. Like P, you have to imagine that. So now OP is the time. OP is time. So P is final time according to our problem. So distance is equal to 3 minus 0. Distance is equal to 3 minus 0. ఇక్కడ నుంచి ఇక్కడికి. సో ఇనీషియల్ పొజిషన్ ఫైనల్ పొజిషన్ మైనస్ ఇనీషియల్ పొజిషన్. ఇనిషియల్ పొజిషన్ 0, ఫైనల్ పొజిషన్ 3. సో టోటల్ డిస్టెన్స్ బిట్వీన్ ఇయర్, how much distance it covered, and this is 3 centimeters. 3 centimeters and time 5 minus 2. Yes, 2 is the 2 seconds is the starting time. 5 seconds is the final time according to the problem A to B. According to the problem A to B. So speed is equal to, we know that formula, speed distance by time. Speed formula distance by time. So distance 3 centimeters, time 5 minus 2, 3 seconds. So substitute 3 by 3, 1. We get 1 centimeter per second according to problem A to B. At B, the distance covered by the body is 3 centimeters. At B, the time is 5 seconds. According to the problem, calculate the speed covered. Speed. So speed formula distance by time. If it is 0 at initial state, then we can take 5 directly, 3 by 5. But 2 is the initial time, 5 is the final time according to this problem, this graph A to B. Then next one, calculate the speed at B to C. Calculate the speed at B to C. Simply it look like a parallel line to time axis. So no change. So speed is between B and C is 0. So the line which is horizontal to time axis, that means the object is at rest. So no distance is covered. There is no change in the state of the body. No change in the distance, that means the body is at rest. అంటే ఈ స్ట్రైట్ లైన్ ఈ టైమ్ యాక్సిస్కి ప్యారలల్గా ఉంది. అంటే టైం పోతున్నప్పటికీ ఆబ్జెక్ట్ ఎలాంటి డిస్టెన్స్ని కవర్ చేయలేదు. ఇట్ డస్ నాట్ కవర్డ్ ఎనీ డిస్టెన్స్, దట్ మీన్స్ ద ఆబ్జెక్ట్ ఈజ్ అట్ రెస్ట్. Then coming to the next one, C to D. C to D. C to D. So distance at C, what is the distance? At C, what is the distance? At C 3. At C 3 only. At D how much? It is the 7. Distance covered at point D is 7. And what about the time? 9. What about the time? 9. So at C time is 7 seconds, at D time is 9 seconds. So we need to take the difference. At C the distance is 3 centimeters, at D the distance is 7 centimeters. So first of all take the distance between C and D. Between C and D, 7 minus 3, 4 centimeters. Then time 9 minus 7, 2 seconds. So speed formula as usual we know distance by time 4 by 2, that is equal to the acceleration or the speed is 2 centimeter per second. 2 centimeter per second. Ila you need to read the graph properly, understand the graph. Slopes should be understood. Slopes, right? The graph between the distance time at different places, right? Different variation. So observe the slopes. Observe the slopes. In distance time graph, the slope of distance time graph is represent speed of the body. Speed of the body, right? Then coming to the next one, the next problem, చూడండి, observe the graph. Observe the graph. Observe the graph. మీకు ఇంకా కొంచెం డౌట్ఫుల్గా ఉంది, గ్రాఫ్ సరిగా లేదు అంటే నేను ఆల్రెడీ పోస్ట్ చేసినటువంటి షార్ట్స్లో చూడండి. కావాలంటే మళ్ళీ ఈ ప్రాబ్లమ్స్కి ఈ గ్రాఫ్ పోస్ట్ చేస్తాను, మళ్ళీ చెక్ చేసుకోవచ్చు. రైట్, అబ్జర్వ్ ద డయాగ్రామ్. అబ్జర్వ్ ద గ్రాఫ్ బిట్వీన్ వెలాసిటీ అండ్ టైమ్. వెలాసిటీ అండ్ టైమ్ గ్రాఫ్. ఫ్రమ్ దిస్ velocity time graph, so we have to calculate some. What we have to calculate from this graph? So from this graph calculate velocity of the body at point C, then acceleration acting on the body between A and B, between A and B. And the third one, acceleration acting on the body between B and C. So from this graph how to know velocity of the body at point C. What is the velocity at point C? And also calculate acceleration between this A and B and B and C. B and C. B and C. Okay, now చూడండి, velocity at the point C. What is the velocity at the point C? At the point C and it is showing at 40 kilometer per hour. 40 kilometer per hour because no change in the velocity here. So 40. So the velocity at the point C is 40 kilometer per hour. Then next one, acceleration acting on the body between A and B. Between A and B. So A, initial velocity, B, final velocity. So time 0 to 3. So we can write now here, according to the graph now, initial velocity that equal to at A 20 kilometer per hour. Then final velocity, that means at B equal to 40 kilometer per hour. See the diagram, see the graph. At A 20 kilometer per hour, at B 40 kilometer per hour. Then the next time at A equal to 0 seconds. Time at B equal to 3 seconds. 3 seconds. At A 0, at B 3. Right. So for understanding, ఇలా చెప్తున్నాను అంతే. Acceleration equal to final velocity 40 minus 20 by time 3 seconds. At B the time is 3 seconds. So we can get 20 by 3, that's equal to 6.67 meter by second square. Hows are doubt? 20, 3 6 are 18, 2.0, mali 3 6 are 18, 20. So like that 6.66 something it will be come. So ila raskoవాలి. So acceleration between A and B is 6.67 or 6.66 meter by second square. Right? Analyze the graph properly, understand the graph properly, then calculating the speed or velocity or acceleration, it become very easy. Next question, acceleration acting on the body between B and C. Let's see the graph again. Acceleration between B and C. Between B and C, is there any change in the velocity? No change. That's why acceleration between B and C is 0. Between acceleration between B and C equal to 0 because of no change in velocity. Change in velocity is 0 between B and C. So this is about the second problem. That means fifth to sixth problem. Okay, coming to the next one, 58th one. So the problem is the speed time graph of an ascending passenger lift given alongside. The problem is the speed time graph. The speed time graph of ascending passenger lift ascending passenger lift is given. So what we have to calculate? What is the acceleration at our first 2 seconds, between 2 second and between second and 10th second, right, and during the last 2 seconds, okay. Now analyze the graph again. See, according to this graph, the maximum speed, according to this graph, the maximum speed is 4.6 meter by second. According to the graph, speed maximum is 4.6 meter by second. Now let us calculate the acceleration during the first 2 seconds. During first 2 seconds. So during first 2 seconds and here to here, this is okay. This is at 2 seconds. What is the acceleration? So initially u అనుకుందాం. సో ఇనీషియల్ స్పీడ్ ఈక్వల్ టు 0 meter per second. Then final speed equal to 4.6 meter per second. Time 2 seconds. Acceleration A equal to final speed minus initial speed, or final velocity minus initial velocity. 4.6 minus 0 by 2, that equal to 4.6 by 2. 2 1 jar, 2 2 jar, 3 3 jar, 2 3 jar 6. 2.3 meter by second square. First 2 seconds. So time is 2 seconds. Final speed or velocity 4.6 meter per second. Initial speed 0 meter per second. Formula we know, acceleration final velocity minus initial velocity by time. So substitute the values and simplify. Second one, between second and 10th seconds. What is the acceleration between second and 10th second? Analyze the graph. At 2 seconds, 4.6 meter per second. Then at 10th second also 4.6 meter. So here no change in the speed. So acceleration is 0. Why? At 2 seconds 4.6 meter, at 10 second also 4.6 meter per second. So no change in the speed or no change in the velocity. So that's why acceleration equal to 0. Next one, during the last 2 seconds. Last 2 seconds in the sense between 10 and 12 seconds. Acceleration. At 10, what is the speed? 4.6 meter per second. At 12, what about the speed? 0. So speed decreasing. So calculate here. Initial speed equal to how much? 4.6 meter per second. Final speed equal to 0 meter by second. At final speed It is 0. At 12 second, 0 at 12 seconds, the velocity or the speed equal to 0. At 10 second, velocity or the speed is equal to 4.6 meter per second. Okay, then time last 2 seconds got it. 12 minus 10, 12 minus 10, that equal to 2 seconds. Acceleration a equal to 4.6 final velocity, sorry, 0 minus 4.6 by 2, that's equal to minus 4.6 by 2, that equal to minus 2.3 meter by second square. So acceleration during last 2 seconds is minus 2.3 meter by second square. That is retardation. Speed decreasing out. Right. Okay, last one. Observe the speed time graph. Observe the speed and time graph. Right. From this graph, how the speed of car changes with time. How the speed of the car changes. The graph given alongside. The graph is given is speed time graph. This graph showing how the speed of a car changes with time. From this graph, what we have to find? What is the initial speed of the car? What is maximum speed attained by a car? Which part of the graph shows zero acceleration? Which part of graph show varying retardation? Find the distance traveled in first 8 hours. Let's start. From the graph, where the car started at 0 seconds. At 0 second. At 0 hour started with A. A means 10 kilometer per hour. So initial speed of the car is 10 kilometer per hour, because the car started at here. The next one, what is the maximum speed attained by a car? Where we have to find the maximum speed? Between B and at B, what is the speed? 35. So 35 kilometer per hour. Which part of the graph shows zero acceleration? Which part of the graph showing acceleration? First of all, between A to B, first is 10, next 35. Speed changes. So here we get acceleration. Between C and D, I think I forgot writing. So much pain. Sorry. D. Between C and D, speed changes 35 to 0. First A to B, 10 to 35. C to D, 35 to 0. But in which case no change in velocity or speed? Between C and C. Between B and C. So that is no acceleration or the zero acceleration. Between B and C, zero acceleration because of no change in velocity. No change in velocity. Next one. Which part of graph shows varying retardation? Varying retardation. So this graph shows varying retardation. It should become like this. Right? Between C and D, velocity decreases 35 to 0. So here we can find out the part of retardation. C and D. Between C and D. Between C and D, we observe that retardation. Okay. Last part. Find the distance traveled in 8 hours. Find the distance traveled in 8 hours. As we know, in a speed time graph, the place under the slope gives us distance traveled. So we have to find out distance traveled at 8 hours. First 8 hours. So here we have the two parts of the diagram, two parts of the graph. First part, see, it look like a trapezium. Then other part, BC here. This part is the second one. It is like a rectangle. It is a trapezium. So between A and B, it is like a trapezium. Between B and C, it is like a rectangle. So total distance travel from here to here. How much means the body covered is like speed, with some speed it covers some distance. How to calculate? The place or the area under the slope. That means we need to calculate this area. This is the area under the slope, gives us a distance travel. For this we have two parts, OAB. Some other part is a trapezium, BC, and some other part is taken as the rectangle. So the area of trapezium and the area of rectangle gives us how much distance the speed covered. So coming to the first part. Area of trapezium. Formula: area of trapezium 1/2 into parallel sides into base. 1/2 into parallel side into base. That is the formula. For trapezium. Area of trapezium. Area of trapezium formula: A equal to 1/2 into sum of two parallel sides into base. According to the graph, according to the graph. Parallel sides are, that's equal to 1 by 2 into parallel sides OA and this part, that is this part. So OA that means 10 into 35, 10 into 35 plus into 3, right? So in this trapezium, parallel sides are this part OA and here this part is the parallel sides. OA 10 here to here, that means it is equal to B. OB just like 0 to 35 the length. This is considered as one side of trapezium. OA is the trapezium, side of trapezium. This line is parallel to this. So these two are the parallel sides. And the base for trapezium is here to here, 0 to 3. So according to formula, half into sum of parallel sides into height. So we get 1 by 2, 45 into 3. By the simplification we get 67.5 kilometer square. This is the first part. Then second part, the rectangle. Second part is the rectangle. So this is the length and this is the width. This is the length and this is the width. Okay, 8 hours between 8 and 3. This gap difference 5. So area of rectangle length is equal to, you taken, this is taken as the length. How much? Here to here 35 is 35 and width or the breadth is equal to 8 minus 3 5. 8 minus 3, that is equal to 5. Area we know, length into breadth, 35 plus 5, 175 kilometer square. 175 kilometer square. So now total distance is equal to area of trapezium plus area of rectangle, that's is equal to 67.5 plus 175. So together we get 240 something, 240 something it will be. So area distance covered total is 242.5 kilometer. 242.5 kilometer. So the distance covered by a car is equal to area of trapezium plus area of rectangle. So total distance covered is 242.5 kilometer. In this way, children, you need to practice, analyze the graph properly, understand the graph properly, understand the slopes, understand the area below the or under the slope, understand the slopes of the graph. Below the slope they give some values. In case of velocity time graph, the area under the slope is distance traveled. The slope of speed time graph or velocity time graph is acceleration. The slope in distance time graph gives speed. So in this way, try to understand the graphs problem. They are also very, very important. So thank you so much. Good night to you all. Hope you understand all.